Alright, so I think I'm recording. We're looking at skill packet 5, exponential and logarithmic equations, and in this skill 5F, we're solving log equations. You definitely need to know your properties of logarithms, these formulas, in order to do these. So on the left-hand side, I have the sum of logs. They have the same base. I can write that as a single logarithm, log base 5. If I multiply 3 times x, the order of multiplication doesn't matter. Whether you write x times 3 or 3 times x, multiplication is commutative. So because these logarithms are one-to-one functions, if these numbers are the same, these arguments must be the same. Subtract 2x from each side, and you have a possible solution of 5. Plug 5 in to make sure that you're not taking the log of 0 or the log of a negative number, because you might get extraneous solutions. So 5 checks out. Let's do problem 4. We'll do these in pairs. Now, even though some people are going to look at this that it says log equals log, it does not. It says 2 times the log. So I can't apply my one-to-one function idea yet unless I deal with this coefficient of 2, and I have the power rule that says that if you have that coefficient, that you can rewrite this as a single logarithm, because right now it's log of x plus log of x. It's 2 logarithms. I can write this as log of x squared. And over here, now I have a log equal to a log. So if the numbers are the same, the arguments are the same, and I have the x squared is equal to 5 minus 6x, that's a quadratic equation. We have several methods to solve quadratic equations. We could complete the square. We could use the quadratic formula. Those always work. And sometimes, not always, we can factor. And in this case I cannot factor. Okay, because two numbers that multiply together to give me negative 5 but add up to 6, I don't have those values that work. So I am going to have to use the quadratic formula or completing the square. So if I identify A, B, and C, let's double check and make sure that I don't have a sign error or something. Let's see. I pulled the 2 up as an exponent. I have 5 minus 6x. I moved this linear term to the other side, so the minus 6x became positive. The 5 became, I don't see any silly mistakes. And a positive 5 times a negative 1 would add up to 4x, and that's the maximum I can get it to be. So I am going to have to use the quadratic formula here. So let's take the opposite of b, plus or minus the square root of the discriminant, which is b squared minus 4 times a times c. And all this is being divided by 2a. And since a is 1, it's just being divided by 2. Alright. Give myself a little bit more room here. Alright, so let's see if we can simplify this. We've got the opposite of 6 plus or minus. We've got 6 squared is 36. The two negatives will make that addition, and 20. So that's 56 over 2 is 4 times 14. I think somebody told me that the other day. Mental arithmetic is not my strength, but I think that's divisible by 4. Yeah, 4 times 14. So we know that we can take 56 and write it as 4 times 14. We know properties of square roots that you can separate that product to where the square root of 4 I know is 2, but the square root of 14 I can't simplify that any further. So I know that I can replace the square root of 56, that's equivalent to 2 radical 14. Alright, so if I have, I'm going to continue up here, negative 6 plus or minus 2 radical 14. We just determined that that's the same number as the square root of 56, and all this is being divided by 2. So with both of these being even numbers, if I factor out a 2 from the numerator, then see, you can't cancel terms. What I'm afraid of is that people will come along and say those cancel, and they do not. You know, those are terms. Now right here, since I've written this as a product, this factor of 2 divided by this factor of 2, it does divide to 1. So, or you could split the fraction up into 2 fractions and divide each term by 2. So we've got negative 3 plus or minus the square root of 14. And there's my final. Well, wait a minute. I need to make sure that that this difference is a positive difference. I may have forgot to mention that yesterday. I didn't catch it until just now. So let's use a calculator. 5 minus and 6 times the quantity. Let's do the subtraction first. Negative 3 minus, well, this should be no problem because of all the negatives. Alright, so let's see what we got here. So hopefully this is a positive value, and it is, so we keep the minus. What about when it's positive, when you're adding these? It's positive, so they're both solutions. If one of those had been negative, I couldn't take the log of a negative number. Now wait a minute. Oh, on the left-hand side, you can see that I do have to throw out the negative 3 minus the square root of 14 is definitely a negative number. Yeah, I've got to check everywhere in the equation, not just one side. Since that's a negative value, I have to exclude the negative and just keep this positive value, right? Because I know that this is a positive number. The square root of 9 is 3. That would be 0. And the square root of 14 is bigger than the square root of 9. So I know this is positive. So this is my only solution. My negative solution was extraneous. Alright, so I hope that helps. And I will do the next pair in another video and talk to you later.